right. Okay. So, give me 1 second and it'll be 2 o'clock. I posted the latest homework. This will be the last homework, by the way, of the semester, which is regular expressions. The final exam will be on regular expressions, but final exam will have regular expressions on it. So, now the reason I teach regular expressions is because they're a really, 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 really good tool. I'm just going to wait until, it is 2 o'clock now. So now I can officially start the lecture in full, because you might be wondering, when in the world does Florida Man have to do with regular expressions? And this is going to be one of those long rambling stories, but I swear to God it has a point. It really does. Now, everybody knows about Florida Man, learns about Florida Man. And if you haven't, I am so happy I get to introduce this concept to you, which is that you can just simply type Florida Man into the news. Florida Man arrested for punching Little League umpire in the face. Let's see. Florida Man's wind blew cocaine into his car. So if you do Florida Man into this, Florida Man admitted to cheating on his wife to get out of the speeding ticket. Florida Man accused of being a dentist. If you come out, it sounds like Florida's full of really crazy people. South Florida Man attacked by a raccoon. Also, the raccoons are apparently crazy there too. You get a week goes by where some amusing headline comes out of Florida, and it makes it seem like everybody crazy is in Florida. Now, there might be something to this hypothesis, as the fact that basically Florida is a very nice temperate climate and it attracts lots of people. It also has alligators and all sorts of other fun things. There's great attractions in Florida. Florida's a wonderful place. A lot of people want to move there, including people who may not be mentally sound. But actually, it has to deal with the fact that, God, in The Good Place, there was this scene where the guy from Florida walked into the bank and he's like, "I'm sorry, we're legally not allowed to have anybody from Florida in here." So just because, it was just great. Miami Times noted that the Freedom of Information laws in Florida make it easier for journalists to obtain information about police than other states. And that's what gets them the news articles. Basically, Florida actually has amazingly strong Freedom of Information laws, meaning that it's very easy to get things that, the policy of the state that all state, county, and municipal records shall at all times be open for personal inspection by any person, which means you get all those great arrest stories, and you can find details about them, there's exemptions, but there's a lot of sunshine laws, which is great for, which makes sense because Florida is just such a warm place, So there is this huge culture of being transparent in Florida, and it kind of carries over, and I am a big fan of open information. The issue, of course, becomes, that there's some personal information that shouldn't be made there. Now, let's talk about the 2016 election, or more specifically, the 2015 Republican primary of the 2016 elections, right? And this is not necessarily to be political about anything. I'm going to talk about Jeb Bush, the former governor of Florida, specifically because this happened to him and it's a teachable moment for a class. And anybody else made this mistake, I would have been doing this. Had we be having a discussion about plagiarism, I would be talking about both Melania Trump and Joe Biden, who at various points had issues with plagiarism. So when I'm on official class time, I try to be as apolitical as I can be, which is not to say I don't have very political opinions. But, so let's talk about the 2015 campaign. Back in the 2015 campaign, Jeb Bush was basically seen as the foregone conclusion as the Republican primary nominee, right? Basically, everybody said, all the corporate backers, all the Republican base, rank and file, basically there were a huge amount of endorsements just already lined up for Republican Governor Jeb Bush. right? So Jeb Bush, for those of you who do not know, because maybe you are not from the United States, is this fella over here, the brother of the former president of the United States and son of the other former president of the United States, George Bush. And both George W. Bush and George H.W. Bush, right? So, he announced his candidacy in 2015 and suspended it in 2016, basically after he couldn't win anymore. But he was known primarily as the governor of Florida from 1999 and 2007. And when you're governor for a while, you adopt some of those values that the state espouses, right? Right? You adopt a lot of the values that the state espouses. The governor from Florida is going to be different from the governor of New York, who's going to be different from the governor of Arizona. They're all going to be very different. Are going to have very different outlooks, regardless of their political affiliations, right? So, anyway, now why do I bring him up, and why are we talking about computer science with him? Well, it has to do with his emails, which for some reason we just you can't talk about 2016 without talking about somebody's emails, right? So, but Jeb Bush and emails specifically talk about what he did is that he, in an effort to show, one of the things that Jeb Bush did was he basically, as governor, right, you can see the headline here that it is not necessarily the greatest headline to have as a candidate. Jeb Bush dumps emails, including social security numbers of Florida residents online. So, again, the social security number is kind of this personal identification number for a U.S. citizen, which is not, in fact, a personal identification number. In fact, my social security card says this number should not be used for personal identification at all. And everybody and their mother has promptly, just basically ignored that, and so I don't think they even bother printing that line on there anymore. We use it as a number because, as the United States, with the federalized kind of government we have, there is strong opposition to getting some kind of national ID on the books, right? And so, in lieu of that, we use like the last 4 digits of our social for pretty much everything to confirm our identity, which is a terrible system, but hey, it's what we got. So anyway. So what he did is that basically, as governor, he basically set himself up as the e-governor, is what he said. He was one of the first governors to really adopt email wholeheartedly. Remember, this is 1999 when he became governor, right? Email was, and it was, that it's really that only like schools and stuff were starting to gain traction with email and stuff. Right, stuff was assumed that you could be done. We started to assume that stuff could be done online on a regular basis as part of regular business for regular folks, right? So, so he, in the spirit of transparency, I'm posting the emails of my governorship, and I guess they forgot to go through the IT guy because here's one email with the redactions done by The Verge. Blah blah blah. Ari blank, dear Governor Jeb Bush. Ari, this person's social security number, blump. This letter is to inform you the facts regarding employment at the House of Hope in Orlando, the vital part of our boys program, right? Basically saying, here, help me with this case. I need you to push through the red tape that I'm going. These are standard emails you might ask for help with the governor, like kind of a long shot, getting somebody and their staff to cut through red tape for you, right? If you are, one of the worst things that can happen to you legally, by the way, one of the worst misfortunes, like something that somebody doesn't do to you, is that you could be declared legally dead by accident. And I say this accidentally, you can totally have it done on purpose, and boy, will that ruin somebody's life. Getting declared legally dead basically makes it impossible for you are basically an unperson. At that point, I might say, go and steal some stuff so that basically the police have to arrest you and acknowledge your existence as a person so that they can legally charge you with a crime by making you a person again. That might be the easiest way to get that solved. I'm not a lawyer, don't do that. Seriously, don't. It's a terrible idea. The best course of action, and really the only way to go through the bureaucratic red tape, is to call up your senator, your representative, or your governor. Those are the only people who can really help you in those times, and it is a pain in the butt. I don't speak from experience. I speak from reading, basically. But like, you can't apply for anything because you're dead. You can't get new credit cards because you're dead. You can't buy property because you're dead, and dead people can't own stuff. You know, it's really tough to do anything when you're legally dead. Can't get a new job because they can't hire a dead person on the books. Can't vote because, I don't know, they don't like dead people voting or something. Something about voter fraud. So, anyway. So, like here, cut through the red tape for this patient. Social Security number, here, health insurance. Right? So, we released this, and a bunch of personal information was released online. You know, that's a bit of a pain in the butt, because if you've got your Social Security number, that's one way you can pwn somebody, right? Identity theft is not fun thing. It is not as bad as being declared legally dead, because you can still fight it. You're legally dead, they just kind of look at you and go, that doesn't happen. It happens. And the issue is that basically, you know, it's a bit hard to find Social Security numbers if you're just simply going to go through documents like that. At least if you're using standard find replace function, right? Right. Everybody's familiar with this. Like over here, I've got a little find. The projector kind of messes with that. Here, put this up over here, and I'm going to just say Social Security number. You can use the find to find the word Social Security number. Stop mashing cold words. Right? But I can't. Can you search for a specific Social Security number? Not using this, not very simply. But the answer is, with regular expressions, you can do stuff like that. You can search for something like a Social Security number. So I'm going to use a website that I like for testing regular expressions. It's called Regexer. So regex, or regex, or however you want to pronounce it. I just will pronounce it regex. Regex. That's just short for regular expression. Okay? Just like how TV is short for television. Okay? And then an R onto the end, because I guess you're doing it as a verb. And what you can do is that this says, here's a bunch of text that we can test a regular expression on. And what a regular expression is, it sounds really boring when I say it, but it's a super powerful find replace function. And in fact, it's powerful enough that basically almost every text editor, almost every IDE, and certainly every word processor like Microsoft Word has it in there. So you learn this here. Every single programming language supports this, as well as a bunch of applications. So this is something, regardless of whether or not you decide to go on with more programming, will be insanely valuable and make you look like a magic wizard, right? You know. So let's go ahead and try this. Hello. This is Karen. I would like you to help me no longer be legally dead. My phone number is, let's go with 123-456-7890, right? Standard. And my Social Security number is, and now Social Security numbers look like this. They look like XXX, 3 digits, followed by a dash, followed by 2 digits, followed by a dash, followed by 4 digits, right? So for instance, maybe their full Social Security number is 12345-6789. And if that's your Social Security number, I'm really sorry that I just kind of just doxed you. But hopefully it's not. So, right, and what we can do is that we can set regular expressions. You can search for stuff like Karen, just like you would normally. Like I'd like to look for Karen. A K followed by an A, followed by an R, followed by an E, followed by an N. Okay? I can also look for just all the E's, right? And it will find all the E's. I can find all the E's followed by an A. There's other things I can do. I can do a lot of other things. But one of the coolest things is like the introduction of what we call character classes, which are not like fighter, thief, mage, cleric, not those kind of character classes. We're talking about classes of different letters, glyphs. So for instance, we can do we can use a simple expression to search for any number. So we can use /D to say, I would like to search for any number. And look what just got highlighted. Every single number. Now, it may be hard to see. I'll zoom in a bit more. Notice that it's like capturing that basically there's a small division through each character. It's just simply capturing each character individually as its own unit. Right? It's saying, we found the 1, we found a 2, we found a 3, we found a 4, we found a 5 at this string location, 102. Then we found, right, this is at 102, a dash, 104. Okay. If you want 2 characters in a row, if you want 2 numbers in a row, you just do simply /D/D. Wait, what's going on? Oh, backslash, I was saying backslash, /D/D. And there, we've got, here's 2 characters in a row, followed by 2 characters. Here's another 2 characters. Here's 2 characters, followed by another 2 characters. 3 Ds in a row. So what we can do with regular expressions is something like this. D, 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 dash. 4 of those, dash. Sorry. If I wanted, it's a, no, I did 4. So it's 3 numbers followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers. And there, that will match any social security number you type in. So say your social security number is 9876-54/321. That should be matched as well. Why is it not matching? Oh, right. No, because I'm stupid. That's why. 987-65-432. There we go. That's why. So it will match any social security number you throw at it. Now you can use this in combination with a find replace function that's built into most programs or most programming languages. And then you could basically replace this with, tools, replace. Place, see, how do I do this? Replace tool does, all right. Yeah, not really sure how to use the replace function. Oh, yes. Okay. Let's go ahead and replace it with redacted and see. And there. So here's the original text, and now we have the text down here that says, hey, my social security number is redacted. So it replaced all instances of that and social security number with redacted. Basically, you could write, whoever released that could have run a very simple script and replace all those things. By the way, this kind of, I don't know if there was any legal fallout from this, but a simple script could have prevented a whole lot of legal liability there. So, we're going to be talking about regular expressions. Now, regular expressions aren't found in the main textbook, the Runestone Academy textbook. Instead, where I'm going to be using that is the Automate the Boring Stuff, which is also on the syllabus. I think he just actually came up with, we've got a new version of, the second edition it just came out, and the online edition will be coming out like very, very soon. But right now, chapter 7 in that book, this is basically learning Python from the beginning, only he kind of does it in a different order and does things that he normally wouldn't put in. He's got a couple of YouTube videos, right? The idea here is, right, again, he says what we want to do is, like, we know that 415-555-1234 is a phone number, but this is not. And yeah, knowing regular expressions. So Cory Doctorow argues that even before teaching programming, we should be teaching regular expressions because, quote, knowing regular expressions can mean the difference between solving a problem in 3 steps and solving it in 3,000 steps. When you're a nerd, you forget that problems you solve in a couple keystrokes can take other people's days of tedious, error-prone work to slog through. Remember, not everybody is tech savvy. You get people who work with spreadsheets and will manually add up everything in the spreadsheet, not knowing that there's a sum function that will do it for them. And then their boss is why it takes wonder why it takes days to get, the next spreadsheet back from them. We're talking there are people whose way of sending an email is to print it out, put and scan it into the printer and send the scans of what they wanted to send using the printer. This is to make things simpler. So how would you write a program? So I'm going to look right here and just kind of show you finding patterns of text without regular expression. Let's say we wanted to find a phone number, which in the U.S., right, phone numbers, by the way, are very different. For instance, I've been getting spam calls from Kenya all of my last not Kenya, Nigeria, all my last class. The phone number, let's see, was 234-803-749-9821. That was 3 digits followed by 3 digits followed by 3 digits followed by 4 digits. Probably not somebody's real number, but that's the number that I got called from. Anywho, in the U.S., we have phone numbers along the lines of, right, 3 digits, so X, 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 with an optional 1 in the front of it for the U.S. country code, because USA is number 1. I thought that would be funnier than it was, so. So anyway, so basically the pattern is, for most U.S. numbers is 3 digits followed by another 3 digits. Sorry, 3 digits in the hyphen, 3 digits in the hyphen. Sometimes though, that's not the way it looks, right? Sometimes it looks like this, right? So without using regular expressions, it gets to be a pain. So let's take a look. So at this function, is phone number. Given some text, tell me if it's a phone number. If the length of the text is not equal to 12, it's not a phone number, right? It's got to have 12 letters in it, right? 3 numbers, a dash, 3 numbers and a dash. Those are 2 groups of 4, followed by 4 numbers. That's 12 letters. Boom, not a number. All right. So let's check. Are the first 3 numbers, are they all, if one of them isn't a number, well, then it's not a phone number. Then you want to check if the one at argument 3 over here is a dash, and then you can see basically we have a conditions. Check to see if the first 3 for loop to go over the first 3 characters, make sure they're numbers. For loop to go over the over this guy, make sure this is a dash. Sorry, if statement to make sure this guy's a dash. For loop to go over these guys, dash, and for loop to go over these guys. And if it passes all the tests, congratulations, you can return true. Pain in the butt, right? So it says, hey, here, this is a phone number, true. Moshi Moshi is a phone number, Moshi Moshi returns false. So, it's fairly straightforward. Call me at, right, so you have to add even more code to find the pattern of text in a larger string, right? Message is call me at this number tomorrow. This number is my office. For message, check if this chunk is a phone number, right? Check if this group of 12 characters is a phone number. And your output would look like this, right? You iterate, basically say, let's take this chunk, and then let's take this chunk, and so on and so forth until you get to this chunk. Oh, that's the phone number, print it out. And keep going and keep going. So it's tricky to do that. So instead, what we're going to do is, so by the way, it says this was 17 lines of code. So we're going to do it in much less. With regular expressions, with 17 lines, and we can only find, the single form, the first format I wrote up. 3 numbers followed by a dash, 3 numbers followed by a dash, followed by 4 numbers. With regular expressions, though, we can find it a bit better, right? We can find stuff that's separated by dots because the person who did it is a monster and used dots instead of hyphens. What about this one? Or what about with an extension? So, again, this regular expression, 3 digits followed by a dash, followed by 3 digits and a dash, that will match the same that you've got for his phone number. So the way we use phone number the way we do this is that we use a library in Python called RE, which stands for, believe it or not, regular expression. Import RE. So that is pre-installed, by the way. That is a standard Python library, so you don't need to install it with pip or anything. Import RE. Right? You'll want to use this anytime. You'll want to use this for basically anything we write because, yeah, let's go ahead and just do it with Geany. Let's go ahead and write it. Okay, boom, boom. So let's do classroom. And again, don't name your program RE because that would be very bad. Phone number regex.py. So let's go ahead and do import RE. Okay. So the way it works is that we create what's called a regex object that will match something. So the way we do that is by saying, hey, now I know my regular expressions, by the way. I don't necessarily remember how it works in Java versus how it works in Python, like what the exact steps to use regex are, and that's okay. But what's important is you know the regex grammar, right? That this is 3 digits followed by a digit followed by these digits. So let's start with this line. There's a lot to unpack here, by the way. Lot to unpack here. Okay. The first thing we need to unpack here, by the way, is this crazy thing. What in the world is that? Right? We know this is a string. What in the world is this? What? Well, remember, back from our first lecture about escape characters, right? Right, if I wanted to say this is a backslash, that gets an error because the backslash is used as an escape character and says I want to escape a string there. So to do a literal backslash, I'd have to do backslash backslash. Except that that doesn't work necessarily because... Oh, right, because that's what it wants to do. It wants to do back... So it will automatically say, here, this is a backslash. Let's go ahead. S is equal to this, S. Python, you're so funny with backslashes. Yeah, I don't... What is the rule for backslashes? I forget. And it's different than every other programming language that I know. Saying that this is the right, notice I get 1 and now I get 2 because it's an escaped character. And that gets confusing. You don't want to deal with escaped characters at all. Then what we can do is say, hey, R, this is the raw string. And what it will do is that say basically these are, take these backslashes literally. There are no escaped characters. There's no escaped characters in this. You just simply interpret it as is. The main reason is that without the R, so the main reason for this is without the R for this, we'd have to put 2 backslashes every time we wanted to do every time we wanted to do a /d. Because we'd have to say I want a backslash there. That would get annoying, so we just simply do raw string. Just remember, use R's for regular expressions. Now this creates a regular expression object. Let's go ahead and print that out. Print phone num regex. Print it out, and notice that it just comes out with gobbledygook. It says re.compile this. Notice it turned it from the raw string into an escaped string. Python does that automatically for you a whole lot, like it was doing for me earlier. Okay. Now the cool thing is that so basically the first thing you do is you compile that regular expression. Okay. And now to get it to match something, you basically use what's called a match object. So the next thing we do is use the search method from the phone regex object. What this does is that this regex object basically says, I'm a searcher. What it does is that I'm going to search for this regular expression. That's my job. You made me with one specific task, and that's the search for this regular expression that you just programmed in to me, which is this regular expression. So I'm going to go and search for it now. How do I search for it? Let's go ahead and, use the search method. MO, and we'll say MO match object. Match is equal to phone number regex dot search. And we're going to do it slightly different than he has. I'm going to say text is equal to, view. Come on. Line wrapping. There we go. Text is equal to, hello, my cell is 770-555-1234. Right? And so if we do this match object.search, and then we do print match dot group, we get, search requires one argument, so we got to search the text. We got to use the regex to search for the text, and that will give us a match. And then we say match.group, which will print out 770-555-1234, which is pretty good. All right. So the idea here is that we can basically, again, it's very easy steps to use regular expressions once we use them. Import the regex with RE, compile it, search it, and then so you create a regex object, use the regex object to search for something that gives you a match object, and then you can use the match to search through to print out the text that you have. So let's print out match and match.group. Match object says it's from 18 to 30 in the input text, and this is what we matched, and then it says, hey, there's the group, which prints out the actual text that we found. So I'm going to go instead and now just talk about like what we can use the regular expressions for. What kind of regular expressions can we build? Let's go ahead. Regex. So let's start with this. So let's go ahead and start from this. Let's go ahead and start with this one. A-E-I-O-U. In between brackets. This is one of the most useful things you can do with regular expressions. Now, we were talking about character classes earlier, right? I mentioned that there's /D to get you a number. So I'm just going to put some numbers here. Right? /D will match two numbers in a row. Right? That's a character class. There's also /W, which matches any letter. I'll review them in a bit more detail in a bit. And /S for white space. That's really what there is. There's W, S, and D, and I'll go back to them in a bit, so don't worry if you miss them. Because right now, I'm talking about there's built-in character classes, but more commonly, you're going to be making your own. So for instance, I could make a character class that says, hey, I want to match anything that's a vowel, A-E-I-O-U, or undercase vowel. Right? Notice it doesn't match the capital E. So this matches, so this is a set says we'll match any one of these in the set. Right, put it between the brackets and it'll match any of these. If you want to match only A, B, C, D, E, this will find only the A's, the B's, the C's, the D's, and the E's. Makes sense so far? You can put anything you want. If you want to just find your punctuation, period, comma, question mark. Right? You can put whatever you want in here and it'll find any of those. Right? Any of those single characters. However, typically we don't, if we were just looking for single characters, that would be fairly easy. Right? A, E, I, O, U. What if I wanted to find two vowels in a row? Well, it would be tedious to, well, you would think, okay, tedious, but I could simply just copy paste and you'd be totally correct. You can do that. This looks for two vowels in a row. An A, E, I, O, U followed by an A, E, I, O, U. Makes sense so far? But there's a shorter way to do that. We can say an A, E, I, O, U. So brackets are used to say create a new character class, a new character group, a new character set. Curly braces, which are those guys that you get when you press shift with the brackets, the curly braces are used for repetition. So it says find exactly two of the preceding thing. If I want to find two A's in a row, I would just simply say A, like this. Aardvark. How do you spell aardvark? I don't know. Like that? That looks right. Aardvark found two A's in a row. Right? It's called, formally it's called a quantifier apparently. But what you use is for repetition. You can say to use at least two. So you can specify a range. I'd like 2 to 5 A's. He shouted, so he shouted, ah, as he went skydiving. Let's go ahead and set up a flag, which is one thing you can do, is to say to ignore the case. So here it says matches 2 to 5 of the preceding token, anywhere between 2 to 5 of these. So we found 5 A's here, 4 A's here, and 2 here. And this gets us into one of the things about regular expressions. Regular expressions by default are what we call greedy, where basically if it has the choice, here it says match between 2 or 5. Now it could have just stopped matching at 2 and then gone for another 2 and then for another 2. But regular expressions by greedy, they try to eat the biggest slice of text they can, right? So given the choice between finding 2 A's and finding 5 A's, it's going to go and try to find 5 A's. So it's going to try to find as many A's as possible, right? And notice that basically that it works for 3 A's in a row, 4 A's in a row, 5 A's in a row. For 6 A's in a row, it just grabs the first 5, right? 2 to 5. Okay. Now, here's where we get into stuff. Now, I want to go on a brief aside here. Regular expressions, I really learned about them where it was the absolute worst place to learn about them. A 4,000 level class called Automata Theory, which basically is the theory of computation and stuff. Regular expressions aren't really that hard, though, even though they have really hard and awesome math behind them, like this kind of stuff. Although it has less to do with trigonometry and more to do with linguistics. For instance, one of the things I keep for my data structure students is the entrance exam to Tokyo University for the graduate school there. And the reason for this is I want to show them like what they're using is like stuff that, what I'm testing them on is stuff that everybody's going to test them on. So bookmarks, maybe over here, no. More bookmark, no. Bookmark toolbar. Come on. search bookmarks on Tokyo. Yeah, here we go. Leave page for right now. That's fine. So this is the entrance exam to Tokyo University for your graduate school. In other words, what you would do after undergrad if you wanted to stay if you do more school, right? This is the entrance exam from 2017. First question, hellish math. Second question, I'll come back to. Third question is on heap sort, which is something you will learn in my class if you take data structures. And then problem 4 is on circuitry and ZORs and stuff, which is not nearly as hard as it seems despite all the math. Problem 2 is about, for a non-deterministic finite automata M over an alphabet sigma, write L of M subset of the alphabet for, or some string in the alphabet for words accepted by M, right? Then write absolute value of W for the length of the word W, right? N for the set of non-negative integers. All right, following the question. Blah, blah, blah. Anyway, what is it saying is that basically it's saying, here we have this non-deterministic finite automata, which is a very fancy way of saying basically it's a flowchart. You start here. If you get an A, you go here. If you get a B, go here. If you get a C, go here. And your goal is to get to here. If you get a B, you go here. If you got a C, you could go here. And basically, it's asking you to find a series of sequences that would get you, that fulfills some of the requirements. Right. So the idea here is it's just weird. It's just a puzzle, to be honest. But these finite automata are basically what we can write regular expressions for. The equivalent of writing regular expressions basically create what are called state machines. They're very basic machines. They create very basic flowcharts that can be followed. They have no memory, and they have some very hard limits to them, such as anything that requires like remembering how many of something you've already found of something earlier of a completely different character can't do that. So anyway, just wanted to throw that. If you want to find out more about those, look up the discrete DFAs, or deterministic finite automata. They're not as hard as they sound. They sound really freaking hard, and they're not, because anything that says deterministic in that sounds hard. And then automata is like one of those scary words. We love to make words scary to scare people off, I guess. It's stupid. All right. Where was I with this? Right. We were doing character classes. So the reason I bring that up is that we use some vocabulary. We borrow some stuff from automata theory to do that. Specifically, we borrow what's called the clean star. Okay. So reg x, right? So let's go ahead and match something. So everybody knows, like, you know, the old Batman song, or at least one part of it, right? Na 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 Batman, right? Don't know how many nanas are in there, right? But it's something like na 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 Batman. I'll go into more detail about this, by the way, in a second. But specifically what I want to use right now is first the plus operator over here, which is something we'll use that comes up a lot from our theory. Specifically, and the grouping. So first off, here we have our NA, which will find all the nanas in na 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 Batman, right? NA. But okay, and next we also have the plus operator, which says, let's say O plus. Now that's not a blood type. What it's saying is that it's 1 O, or 2 O's, or 3 O's, or 4 O's, or 5. Or in fact, as many O's as you can get. The plus operator means, of the preceding thing, I'd like at least one, please. So this will match. So for instance, O plus A plus will match O up and O up and O up and so on and so forth. Right? It'll match this it'll match this, right? Any number of O's followed by any number of A's. Or rather, not any number of O's, right? Any number of O's would include 0. You got to have at least 1 followed by at least 1 A, right? So if I just did a bunch of A's, that wouldn't work. If I just did a bunch of O's, that's not going to work anymore, right? At least 1 O followed by at least 1 A. Question so far on this operator over here? Yes? If I were to switch OA, OA, very good question. What it would do is that it would match OA, and it would match OA, and it would match OA, but it would not match the whole thing, right? It would match each of the OAs individually, right? Now, what we could do, to answer your question, is that we could take this, and this is future-proofing this, put it in parentheses, and add a plus to that, and it'll match OA followed by OA followed by, it'll match any number of OAs in any kind of configuration like that. Anyway, where am I going with this? Right, okay. But we've said that, so one thing we can do is, so this is at least 1. We have one other operator, which is called the clean star, or as you know it, the asterisk. The clean star, and the clean star is not spelled like Mr. Clean. It's spelled K-L-E-E-N-E. The clean star is this. And notice that it matches what we've got matches for now. We've got matches for any O followed by any number of A's, including 0. So the clean star is like the plus, but it literally means any number. Could be 0 or more. So an example of this, let's go ahead and talk about British English for a second, right? We could do, for instance, right, British people spell things longer than Americans. Like, we like to spell color, right? But they're fancy, and they will add a U into it, right? Color, right? Like that. Okay. And I'd like to match both of them, please. I'd like to basically be as Anglo-unified as possible here, okay? So what I could do is I could put U with a clean star here, and this will mean 0 or more of those, right? So it'll match both color and color, right? It'll match both the British spelling and the English spelling, right? It'll match both 0, right? Notice it's going a C followed by an L, C followed by an O, followed by an L, followed by an O, followed by any number of U's, followed by an R. And that happened to be 0. Okay? And now over here we've got a C followed by an O, followed by an L, followed by an O, followed by any number of U's and an R. Mind you, it will also match this color. So that wouldn't necessarily work. So if you just want it to be 0 or 1, there we have one more character. And I'll stop for this kind of stuff and go back to using these. If you use a question mark, that basically means 0 or 1 of these, please. All right. So let's go and go back to our textbook now. Okay. So one thing we can do is that we can use groups with parentheses. Like, say we wanted to isolate the area code from the phone number. We can use something called grouping. So notice what we've got over here. We've got parentheses around the first 3 digits and then parentheses around the next bunch of digits. And now let's see how what that's going to alter things when we run this program. So if I instead change this to having parentheses around, let's see how this changes what we do. Right, and basically what that will do is this will treat each group, everything in parentheses, as a discrete unit of text. So doesn't really change anything there. But so it doesn't really change anything there. Whoops, let me close this. I don't need this. But what we does change is that if we decide to do, say, go back here. So we've got our match object, print match dot group 0 map dot group 1 and then group without any arguments, and let's see what happens. So I think we need group 2 and then group without anything. There we go. So, sorry. So we've got our text to match here, 770-555-1234. We've got our phone number over here. Now, printing out the match object just gives us that. Printing out group 0 gives us the entire thing that's been matched. Group 1 gives us the first group. Group 2 gives us the second group. And group without parentheses does the same as group 0, which prints out the entire match. But basically, we could just simply find, if we wanted to, we can find just one section over another, which is really nice and useful. Okay. You can also use groups plural. What it will do is that will give you both the groups for those. Let's see. So now let's go ahead and now because parentheses have special meaning here it's one of those, so parentheses have a special meaning in regular expressions. So say for instance I wanted to find basically, right, remember how question marks had a special meaning here? We've got one question mark that basically says, hey, question mark means an optional number of the ones before me. Well, if I want to get a literal question mark like this, then I would need to do / question mark to match a question mark. Right? I'd have to escape the question mark to actually match the literal question mark, and then do plus to match at least one of them. Like that. Same thing for parentheses. So say I wanted to match the following. So say I wanted to match the phone number in terms of, in this, let's see what we've got. We've got open parentheses and then escaped open parentheses so that it will match a literal parentheses, right? This will create a group, right? Let's go ahead and see this in our text over here. This will create a group over here, right? These parentheses create groups, but now I've added these parentheses and these parentheses, right? Notice that they're highlighted together. These are escaped, meaning it's literally looking for something like this. It's looking for begin group, open parentheses, a digit, a digit, a digit, a close parentheses, close that group, a space, create another group with 3 digits, a dash, and 4 digits in it. So we run this, and we get here, and it matches this 770-641-006. Let's see. 770-555-1234. Let's see. Let's see. MO group. Matching multiple groups. All right. So let's take a look over here. So we've got something called a pipe character. You can use it to basically Now, in a lot of programming languages, the pipe character, that's basically on the backslash, that shift backslash. You can basically use it anywhere you'd want an or. So, for instance, Batman, then the pipe, Tina Fey, will match Batman or Tina Fey. Okay? So if Batman or Tina Fey occur, then it will just simply match the first thing. So search Batman, Tina Fey, it will return Batman. Tina Fey and Batman, it will return Tina Fey. Later on, we'll use something called the find all method. But really, all you need is group for the assignment, because what you're going to be doing with the assignment is that you're going to be creating a regular expression object and or a lot of different regular expression objects and iterating through all the words in a file, right? To find all the words in the file. So one line at a time, each with a single word in it. So here, for instance, is a fairly good one. Right. So let's create a classroom. This one's very good for our uses over here. Batman regex. Right? So let's go ahead and say what we need. So we could do, so import RE, save as .py, bat regex is equal to re.compile, and basically all the bat stuff we'd like to, with Batman we'd like to compile. So for Batman, we'd like to do bat compile bat, and then bat should be followed by one of many things. So let's go with Batman or woman. Batman or woman. So notice over here that we're using a group in conjunction with an or operator. Bat text equal to Batman delivers a fearsome kick to the Joker. Great. So let's go ahead and do bat regex dot match the text to find the text, which will create our match object. I think was it match? No. And then then print match dot group, which will find our first match there. So it finds Batman. And if I change this to bat, and remember, what is this looking for? It's looking for a bat followed by either a man or a woman. So if I do bat woman, it will find Batman. So let's go with the bat. So the bat woman delivers a fearsome kick to the Joker. So what did they mess up? Match that group. None has no. What do you mean? What did I mess up? How weird. What? Oh, I should be using search. That's right. Batwoman. It's different for every language, which is annoying. And I have to juggle between knowing Python and the way it works in Python and the way it works in Java. It kind of gets frustrating. So here we can look for Batwoman. Let's go ahead and make this a bit more involved. We can match Batwoman, Batmobile, What's another bat thing? Bat. Shark repellent. True story. The Adam West Batman was something else. Let's see. Bat plane. Okay, so if we change this to the Batmobile delivers a fearsome kick to the Joker, then it will match that as well. We can also change, by the way, make this both simpler and more complex. The Bat, put another group here, whoa, question mark. So this will match either Batman or Batwoman. The whoa there is optional. Right? And notice how basically it just looks, these are all different options, right? It will look for bat, woman or man, mobile, shark repellent, or plane. Any of those followed by a bat. Or sorry, any of those following a bat. Okay. Again, we already went over the question mark, right? Batwoman, The Adventures of Batman, The Adventures of Batwoman, right? This will match that optionally. Similarly, we can like optionally match the, let's see, whether or not it has the area code or not. Here's another one, the Bat-Woe Starman, which will match Batman, Batwoman, Bat-Woman. And plus will match Batwoman, Batwoman, but nothing for Batman. So there's a lot of stuff you can do with this, with regular expressions. The final thing I want to leave us off with, well, not final thing because we still have 20 minutes, is going more into detail into the setup character classes that we already have set up, or the built-in character classes that we have. So, for instance, we've got, let's go ahead and just reset this. So here, we've got a expression. First off, /W matches any alphanumeric character, which is alphanumeric and underscore. Basically, if you could throw it into a variable, it would match it. So, for instance, my string would be matched by that. Right? If I were to simply do the plus operator, so this means any series of alphanumeric characters. Now here's an interesting thing. So notice that's lowercase w. What did switching it to uppercase W do? So this was lowercase w. What does uppercase W do? Sorry? Not that. Very good. Sometimes the simplest answers are the best answers. Not that. Yeah, it inverts the search. It will do anything that's not alphanumeric. Right? Anything that's not a letter or an underscore or a number. So given that, what does /D do? Right? /D, that matched a letter. Oh, sorry, not a single number. So what does /D match? Right? Logical extension of /W. /W matched anything that was not alphanumeric. So what should /D match, the capital D match? Not a number. Anything that's not a number, /D will match. Right? If I throw some numbers in here, doesn't match them. Okay? So you've got your D, your W, and these, by the way, I list on the exam because they're on like the help page on the exam because they're super useful. Okay. What about, okay, we've got one more built-in character class, which is /s. What is that matching? I keep hearing it. Yeah, it's matching spaces. Specifically, it's matching white space. It will match any space. It'll match a tab. It'll match like the line breaks, the /ns that you would get. So it matches anything that's white space. Anything that separates words from one another. And so capital S is anything that's not that. All right, we have one more thing that's not quite a character class, but it falls under something that's the same category, which is, all right, remember we were looking for, in our practice exam that we did, we had a cat, but the middle letter could be anything, right? So we had cat, but we also had K4T, right? Well, the anything character is a period. Period is the wildcard character in regular expressions. Now, if this is getting to be a bit much and a bit unorganized, click here, cheat sheet. So let's go ahead and take a look. Character classes. Anything that's in any character but a new line. Word character, digit character, white space. Not a word or digit or white space. This creates a new class. Any of A, B, or C. This is one we didn't go over. That finds vowels, A, E, I, O, U. If I put a caret up here as the first character in there, it suddenly inverts it. Not A, E, I, O, U. So you can invert your own character classes. That's useful, not vowel. Why am I focusing on talking about vowels? Because I've got a number of questions that revolve around repeated vowels or vowels that are separated in the homework. Okay. Anchors, these are useful. A caret outside is a special character that means the beginning of a line. So, for instance, this means any C that at the beginning of a line over here. Flags, multi-line. Here we go. So C, right? Notice it's matching only these C's, but it's not matching the C's at the end of over here at the end of a line. Right? These cheat sheets are great. And then, /B, word boundary, which you don't really need to worry about too much. We'll talk about the grouping some more, but basically it's got pretty much everything over here that you want, that we've been talking about today in class. Now, the easiest... now let's talk about your homework some before we're done with the class. Okay? Now, I posted your homework a bit ago. It's not too... There it is. You're going to be your last homework, in case you didn't catch that. And it puts a lot of stuff we did together with file reading and other stuff. Why are you not connecting? Temple Wi-Fi, you are useless. But mind you, I feel like every single college Wi-Fi is kind of useless. It's not just Temple. Like I've not found a giant Wi-Fi network that I haven't had a problem with. Oh, what am I doing? I probably have it on my computer. So I can just simply pull it up on here. Teaching, ITP, assignments. So regex and parsing. Here we go. So it's 4 pages, or rather 5 pages, 4 pages of actual exercises. Each of the pages are worth 25 points. Okay. The first is the regex dictionary, which is that I want you to, I have a dictionary file in word.txt. If you're on a Unix system, you get like Macs, you can use the dictionary file included on your computer, which is basically the library of stuff for spell checking, which is located in /user, /share, /dict, and then whatever, I don't know, directory. What's inside there? American English. So let's see, cat, that. And there's all, and that printed out all the words in my dictionary. Okay. So some words begin with capital letters. So so basically I want you to give me the answer and the regular expression for each of these. So you'll want to both program them and also answer it. So I like animals. How many words contain cat and dog in them? Right? That can be solved without using regular expressions, but I'd rather you get some practice. 4-letter words are supposedly naughty. How many 4-letter words are there? Again, you can do that with regular expressions or without regular expressions, but I'd like you to use regular expressions to get practice with it. I'm scared of pyramid schemes and MLMs. Again, how many contain hun? Now here's another one. Do more words end in ing or ion? And now we start getting into the parts where we really need to start using regular expressions. First 4, you can kind of make do without them. But now, how many words contain Q not followed by a U? Now you might be wondering, like, Q always followed by a U. Well, what about Qatar? That's a country, name of country. Doesn't have it's a Q, not followed by a U. Iraq? Q, not followed by a U at the end. How many words have no vowels in them? Y is not a vowel, by the way. I don't know why they have that. Sometimes Y is a vowel. It's not true. How many words are only have vowels in them? How many words are contracted with not, meaning they end with nt? I think there's 0 in here in the dictionary. It should be it should be n quotation mark t. So that's a typo. How many 2 vowels in a row are there? How many words with at least 2 vowels are there in there? And so then here's a link to regexer in case you forget where it is. Some of this will require reading also or listening to me in class. What's the difference between dot star and dot star question mark? Create a regex that will match somebody with the last name of Nakamoto. Create a regex that matches the strings 20, 21, 22, all the way up through 99. Not the entire, it doesn't match the entire string. It matches 20 or 21 or 22 or 23 and so on. And then finally make a string that will match dollar values, such as the following of these. Strong password detection. So it tells me whether or not something is a strong password or not, right? Basically, it's got to be at least 8 character long. It's got to have both uppercase and lowercase characters. It's got to have at least 1 digit in it. So given a password, tell me whether it's a strong password or it's a bad password. And then finally, number 4 is let's throw out the previous problem and actually create good passwords. Let's create a good password generator. Because this is a terrible password. Uncommon, not base word. Capitalize it, make some common substitutions, add some random punctuations and stuff. It takes about 3 days to crack that password. 1,000 guesses a second. Easy to guess, hard to remember. Was it trombone or troubadour? Was it a 0? Or was one of those a 0? And was there some symbol? Hard to remember. But if you use 4 random words instead, like correct horse, battery, staple, hard to guess, easy to remember. You just remembered it. Correct horse, battery, staple. So create a password generator that will be easy for you. Now, what's great about this is that you can actually use this to generate the passwords you need for a temple, because temple's great. And so long as you have passwords of at least 16 characters, you can use it with, you can just do undercase characters, which is awesome. Like, kudos to the IT department for that. All right. So that's your homework, your last homework. Get this done and you are done until the final, essentially. Okay, we will keep going over the regular expressions both tomorrow and when we get back. And I say tomorrow, I mean Thursday.